So today we're going to be talking about specific latent heat. Okay, and when we're talking about specific latent heat, we need to remember that it is different from specific heat capacity. Okay, which was the previous subtopic. So previous subtopic was specific heat capacity, and uh, the specific heat capacity has to do with the rise in temperature. Okay, the rise in temperature. But specific latent heat, specific latent heat, they, first of all, we have to understand the meaning of the word latent. Okay, latent in last time in the old books it used to be called hidden, means dia tersembunyi tau. Okay, yeah, in a sense dia tersembunyi. So it used to be called specific hidden heat. It is a heat that is hidden, like you are providing the heat, but you don't see the effect of the heat. Because for us, whenever we think about heat, we think about temperature increase. When you provide heat to something, the temperature of that thing will increase. Okay, but there will come a time when you provide the heat, and then you're like, how come the temperature is not increasing? You put the thermometer. Say for example, you want to panaskan air lah, you want to heat up water. Okay, you want to heat up water. So initially, when you are heating up water, you find that okay, temperature increase, temperature increase, temperature increase. Then there will come a time where suddenly the temperature will stop increasing, although you're still providing heat. You're still giving the water heat, but then suddenly the water is like, how come the water stop increasing temperature lah? Okay, so we need to answer this question: what is happening to the heat that we are providing? Okay, so that's why we call this specific latent heat. It's a heat that is hidden. To us, it looks like the heat is not doing anything, but actually it is doing something. It is just not increasing the temperature. Okay. Secondly, before we begin, I want us to remember the fact that I told you the last time that when the temperature is increasing, okay, when the temperature of a material is increasing, means that the kinetic energy of the molecules, okay, is also increasing. This is a thing that we must remember before we start this specific latent heat. Okay, because in the previous subtopic, specific heat capacity, when we provide the heat, we are actually making the molecules move faster. Okay, we're making the molecules move faster, and that's why the temperature increase. Okay, that is the previous subtopic, specific heat capacity, because it involves either an increase or decrease in temperature. When we take away the heat, okay, the kinetic energy of the molecules becomes lower. That's why the temperature decrease. Okay, so previously in the past, when you learn science, we only understand, provide heat, temperature increase. So now in physics, we are making that link. When we provide the heat, we are actually making the molecules of whatever that we're heating, we are actually making the molecules move faster. We're increasing their kinetic energy. That's why the temperature increase. But in this subtopic, we find that the temperature does not increase, but yet we are still providing the heat. So the question is, what is the heat doing? If it is not making the kinetic energy of the molecules faster, okay, or bigger, okay, what is the heat doing? What is the purpose of the heat? That's why it's called specific latent heat, or in other words, it's called specific hidden heat. We don't use the word hidden now. We have to use the word latent because it is a more acceptable term. But we understand it as hidden. Okay, it is a heat now that looks like it's hiding somewhere. Like, what is the heat doing? But actually, it's doing something. Okay. So let's begin. The ice kacang okay, the ice kacang in this case, which is colder than surrounding, is actually absorbing heat, okay, from the surrounding air. Okay, of course, we notice that the changes that happen to the ice kacang is the ice kacang changes from solid to become liquid, and it melts lah. Okay, it becomes from solid to liquid from the process of melting. The process is called melting process lah. Okay, same thing. A fish can be cooked by steaming in a steamer pot. One of my favorite ways to cook fish actually is by steam fish. I love steam fish. Okay, I like steam soup also. Steam soup also very nice. Okay, now what changes happen to the water? So there's, when you steam fish, okay, fine. If any of you have experienced steaming fish, you know that you steam fish by putting it on a bed of water. Lah. Of course, you separate it. You don't put it in the water. Okay, you put a layer of water and you put something on top, and you put a fish on top of it. Okay, so what changes happen to that water? Okay, the water changes from liquid to steam, okay, or to vapor. Okay, by the process of, what is the process called? It is called boiling. Okay, you boil the water. Lah. Okay, so the changing from solid to liquid is melting. Changing from liquid to steam is boiling. But in physics now, we call this word melting and boiling a different word, lah. Okay, which is what I want to introduce to you today. Okay, so let's recap a little bit. Elements can exist in three states, okay, which is solid, liquid, and gas. We call these three, solid, liquid, and gas, the three states, okay, of matter. Okay, in Malay we know it as tiga keadaan jirim lah. Okay, matter, all matter, all, yeah, things in this world are all made up of matter. So all matter, okay, is made up of these three states, which is solid, liquid, and gas. And the most famous example for us is, of course, H2O lah, okay, which is water, which can exist in solid in the form of ice, liquid in the form of water, and gas in the form of steam or vapor. Okay. Now the most important thing that we need to understand from these three states of matter is how the molecular bonds are. In the liquid, the molecular bonds are very strong because they're very near to one another. So their bonds are very strong. Okay, they are linked to one another, lah. Okay, so they're very strong. In liquid, they're not as near as solid. Okay, so they are less strong. They are strong, but they are less strong. Okay, the less strong molecular bonds in liquid. Gas, however, has the weakest molecular bonds. Okay, the bonds between gas molecules is the weakest, and because of that, they can move freely at random. So they move here, they move here. After they move here, they move here. After they move here, they move here. Up to them, lah. Okay, they're very random molecules. They just move wherever they want because they are not, mereka tidak terikat kepada satu sama lain. They are not linked to one another. Okay, they have no responsibility to the person next to them. Okay, whereas solid, no choice. They are already so compact together. Okay, and they are already linked to one another. So they are very strong together, lah. Okay, now bear this in mind as we discuss this. So let's take a look at this case. When we heat the ice in the water, when they heat the ice, that we put the ice in a beaker, okay, and then after that, we put a thermometer inside, and then we heat up the beaker, lah. Okay, this is a very natural situation. We do this almost every day. Okay, I don't think I've seen anybody heat up ice. Okay, but it can happen, lah. So, question number one, do the temperature of the reading increase? Now, actually, what you will find is that at first it will increase, but actually, what happens is that the temperature remains the same for quite a while, Okay, what is the effect of the heat supplied to the ice? Okay, what happens is that the heat is absorbed by the ice that is used to break up the bonds between ice molecules. Okay, this is something new. Okay, something new. So let it slowly sink in, lah. Okay, while you're copying down now. Okay, I hope you're copying down. While you're copying down in your module, okay, let it slowly sink in that when the temperature remains the same. Okay, ice naturally is at 0 degrees Celsius. Even when you provide heat, it will remain 0 degrees Celsius for quite some time, actually. Okay, it will remain 0 degrees Celsius for quite some time before it finally all melts. Okay, So what is happening here is that the ice, okay, the ice is changing to water, okay, alias the solid is changing to liquid, okay, or either we know that as this form is changing to this form. Okay, that's why this sentence over here is very important. The heat absorbed by the ice is used to break up the bonds between the ice molecules. Okay, put a star over here and write down that's why, okay, there is no temperature change. Okay, because now the heat the heat is being used to break the bonds between the molecules. Okay, remember in specific heat capacity I said when there is a temperature change it involves the kinetic energy of the molecules. Okay, when there is a temperature change it involves the kinetic energy of molecules. When the temperature increase it is because the kinetic energy of the molecules is increasing. Okay, but if there is no temperature change and we are still providing the heat, therefore we can conclude that the heat is being used to break up the bonds between the molecules so that the solid can become a liquid. And this gives us one very, very important thing that we must remember when we're talking about heat. Heat can only do one thing at one time. It cannot do two things at one time. Okay, it is either increasing the kinetic energy or it is breaking up the bonds between the molecules. It cannot do both at the same time. Cannot. It's either this or this. Okay, and how do we know what is the heat doing? The temperature will tell us. The temperature tells us whether the heat is being used to increase the kinetic energy or whether it is being used to break up the bonds between between the molecules. Okay, doesn't matter changing from solid to liquid or liquid to gas or the other way around. Okay, and this is a very important thing that we need to remember lah. Okay, I think in higher level physics there is a name for this lah. I can't remember which law it is lah. Okay, but it's a very important thing that we need to remember. We need to unlearn whatever that we think we knew in the past. Because in physics, it tells us heat can only do when we provide the heat. Bila kita bekalkan api, haba, okay, haba itu boleh digunakan untuk satu benda saja pada satu kali. It can only be used for either this or this. Cannot be used together. Okay, unfortunately lah. Okay, unfortunately, heat can only do one thing at one time. Either you make the molecules move faster, which is increase the kinetic energy, okay, therefore you increase the temperature, or you break the bonds between the molecules, which means there's no temperature increase, but you're still working. The heat is still doing its job, okay, but it's a different job now. It can only do one of the two jobs. It cannot do at the same time. Okay, very important thing we must remember as we go into this subtopic. Next, heat the water in the beaker. So now we are using the same thing. Okay, all the ice has melted to become water. Okay, what is the effect of the heat to the water? We find that the temperature of the water rises up until 100 degrees Celsius. That's normal lah. And when we provide the heat will rise until a certain temperature, which is 100 degrees Celsius. Now, what is happening here? Temperature of the water rises up means what? It means that the kinetic energy is increasing. Is it breaking up molecules? No. Okay, as I said just now, heat can only do one thing at one time. If it is not breaking up the molecules, it is making the molecules move with a bigger kinetic energy. Okay, and that's why the temperature of the water rises. Okay, when we understand this, when we understand the fact that heat can only do one thing at one time, okay, this topic will become very easy for us. Okay, as long as we think that heat can do a lot of things at one time, that's where we get stuck. That's where we make all these mistakes, okay, in our understanding. So we need to make sure that it is drummed into our heads. Oh, heat can only do one thing at one time. Okay, it cannot multitask. Yeah, it cannot multitask. It can only do one thing at one time. Okay, now temperature rises until 100 degrees Celsius. Let's continue to heat. We continue to heat even though the water in the beaker starts to boil. Okay, the question is the temperature rising? The answer will be the temperature remains the same. Temperature doesn't change. Okay, although, yeah, it is true. No, cuba kau masak Maggi. Okay, sorry, when let's say you cook Maggi, you boil the water, right? You put the thermometer inside, you will realize that okay, it will rise until 100, right? Then it will stop rising for a while. It will. It will stop rising for a while. Okay, the temperature remains the same, but you are still providing the heat. So what is the heat doing? If there is no temperature increase, it means that the heat is breaking up the molecules between the water molecules. Sorry, breaking up the bonds between the water molecules to change the water to become gas. Okay, so we are coming back to these three states of matter again. Just now, ice changed to water, break up molecules, become liquid. Now, liquid, we're boiling it. Okay, so we're breaking up the molecules some more so that it can turn into gas, so that it can turn into water vapor. Okay, so name the heat that is absorbed or given out during the change of phase. Okay, so these are two important words, two important phrases that you need to remember. Okay, latent heat. Latent heat is the heat that you either absorb, okay, when you provide heat, you absorb lah, or you release, okay, when the temperature is constant. Okay, and because the temperature is constant, there will be a change of phase. Change of phase means solid become liquid, liquid become gas, gas become liquid, liquid become solid. That's called changing phase lah. Three phases, solid, liquid, gas. Okay, these are the three phases of matter, three states of matter. So when it is changing the phase, okay, there is no temperature increase. Why is there no temperature increase? Because the heat that you provide is used to break the molecular bonds. Totally different from the second subtopic. Second subtopic is specific heat capacity. Specific capacity is you provide the heat to increase the temperature. Okay, why? How does the temperature increase? When the kinetic energy of the molecules increase. Okay, so totally different. This subtopic is now about no temperature increase because the heat is being used to break the molecular bonds. Okay, and it takes a lot of work lah. It takes a lot of work to break up a friendship. Wow. Okay, it's a lot of work. Okay, you provide a lot of heat because you want to break the molecular bonds. Okay, so it's actually it is much easier to provide heat. It is much easier to increase the temperature than it is to break the molecular bonds. It is. That's why you will find that actually latent heat, the values are very, very big, compared to specific heat capacity. Because specific heat capacity, all they need to do is just make the molecule go faster only. Okay? But latent heat, you want to break up the bonds between the molecules, and that takes a lot of work. Okay, just like this is a very bad example. Just like if you want to break up a boyfriend and a girlfriend, this is very evil. Okay, if you know if you let's say if you know a couple and you don't like them and you want to break them up, right? It's not just a matter of it's not a very simple thing to do lah. Okay, it's very long and very there's a lot of work that goes into this breaking up people lah. Sorry, this is a very bad example, but I hope that it makes a point. Okay, so the change of phase in matter or change of states in matter. So this is again, as I said, during the changes of phase in matter, such as melting and boiling, the temperature remains constant. There is no increase in temperature, which is strange to us. Okay, because to us, when we first learn science, okay, we always think that if you provide heat, sure the temperature will rise. The moment you stop providing heat, then the temperature will either turun or. But in physics now, we learn something new. We learn that sometimes you can provide heat, but there is no change in temperature. Okay? Because what is the heat doing? The heat is its job to break up the bonds between the molecules. So latent heat is the heat that is absorbed during the melting and boiling, okay, without a change in temperature. Okay, so when and heat is absorbed or released lah. Okay, so for example, if it's melting, okay, latent heat will be absorbed because you're changing from solid to liquid. So solid to liquid to gas, all the heat is absorbed. Kita menyerap haba. But from gas to liquid to solid, okay, we find that the latent heat is released. We release the heat, the molecules release their heat so that they can join back together. Okay, so a lot of new words, okay, a lot of new words, a lot of new ways of thinking, okay, but it is basically that think at the molecular level. When we absorb the heat and we are not moving any faster, it's because we're breaking up with the people next to us. We're breaking up with the molecules next to us. But when we release the heat, okay, when you lepaskan garam lah, okay, then wow, friendship can happen and everybody says sorry and we come back together. Wow. Okay. This happens in real life, I guess. Okay, so when we release the heat, okay, the molecules come back together. Okay, so think of it in these two ways. Okay, if you want to break people up, you gotta absorb the heat. Okay, you become very hot so that nobody wants to come near you. Okay, break the bonds. But when you open your heart, when you open your heart and you release all the anger that is in you, people will come nearer to you. Wow. Okay, and they were like, oh, okay, we're best friends now. Blah 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 blah. Okay, so latent heat, as I think this one you should have already copied by now. Okay, remember that solid is in this form, very tight, very close. Okay, liquid is kind of meh, okay, like halfway lah. Not very tight, not very close, but not very far either. And gas is just like a bunch of independent people on their own. Okay, they're very hot because they have a lot of heat in them. Okay, and they're just constantly moving around very randomly. Okay, change of phase, remember these words, change of phase these are all phases. Gas, liquid, solid, these are all phases. So the four main changes of phase, okay, as I said just now, solid change to liquid is melting, liquid change to gas is boiling, okay, gas change to liquid is called condensation, okay, and liquid change to solid is called freezing. That's very normal lah, kan? Freezing, we know this. Okay, but the important thing is this, in these changes of phase, we have to know when the latent heat is being absorbed and when the latent heat is being released. Okay, that's a very important thing. And these are the four main. Let's not talk about solid change to gas and gas change to solid. We're not interested in that. Okay, because that is a different situation altogether. So melting, boiling, freezing, and condensation. Okay, now this is another chart. I'm not sure if this is in your module, but this is another chart that kind of shows this. There are two types of latent heat. Okay, there are two types of latent heat. The first latent heat is called the latent heat of fusion, and the second type of latent heat is called the latent heat of vaporization. Two types of latent heat because there are two changes of phase. One is a change of phase between solid and liquid, and one is a change of phase between liquid and gas. Okay, so that's why there are two types of latent heat. The first one is latent heat of fusion, and the second one is latent heat of vaporization. Even the word vaporization, also you kind of already know where this is going. Okay, so the heat absorbed for a substance to change from solid to liquid at a constant temperature is called the latent heat of fusion. Okay, whereas the latent heat of vaporization, this one, is the heat that is absorbed for a substance to change from liquid to gas at a constant temperature, either liquid to gas or gas to liquid. Okay, but since we're talking about heat absorbed, okay, we are talking about the change between liquid to gas. Okay, so which means that when melting happens, okay, when melting happens, when solid is being changed to liquid, latent heat of fusion, latent heat of fusion is absorb. ORBED. Okay, latent heat of fusion is absorbed. When liquid changes to gas, when water changes to gas, lah, okay, latent heat of vaporization is absorbed. Okay, but what if it is the other way around? Okay, what if liquid is changing to solid? What if water, you freeze water and it becomes ice? Okay, what happens over here is that the latent heat of fusion is released. Okay, you release heat in order to change from liquid to solid. When you get colder, you release heat. Same thing, when gas becomes liquid, okay, by process of condensation, we say that the latent heat of vaporization is released. Okay, so we are giving names to the heat that is being absorbed or released. Why is it two different names? Okay, it's all latent heat why cannot be the same? It's the same thing. All this is H2O. Why is it different? Okay, because latent heat of fusion is to change from solid to liquid. You want to break the molecular bonds from solid to liquid. Latent heat of vaporization is you want to break the molecular bonds from liquid to gas. Tell me, between this and this, which is harder to break up? Okay? Of course, it will be the liquid. Liquid change to gas requires more heat energy to break up the molecular bond because they are already not near to one another. Trying to break them up some more, Okay, it takes a lot more effort. So latent heat of vaporization is very, very high. Okay, it requires more heat to break up all these molecules so that they can turn into gas. Okay, so again, a lot of information to absorb in one day. That's why I think today is just like information absorption saja lah. Okay, but it's such a very important base for us to understand this. Okay, let me repeat this. Astaga. Okay, so we need to add the words here. When melting happens, latent heat of fusion, okay, is absorbed. When boiling happens, latent heat of vaporization, okay, is absorbed. When gas changes to liquid, latent heat of vaporization, okay, is released. And when freezing happens, liquid changes to solid, latent heat of fusion, okay, is released. This you need to remember. Okay, the four main processes and what kind of latent heat is being absorbed or released. That one you need to remember. Okay, so it's not just enough to know about heat, we have to know about latent heat. And it's not just enough to know about latent heat, we have to know the two kinds of latent heat. Okay, fusion, vaporization. So the next time you boil water to cook Maggi or you boil water to drink your Nescafe or you drink your Milo, think of it in this sense. Okay, oh, I'm boiling water. Means I'm providing latent heat of vaporization so that the water can change to gas. Actually, technically, okay, which we'll come to later, technically what you're providing is you're providing heat capacity first, okay, because you want to make the molecules become faster. And then at a certain temperature, at 100 degrees Celsius, okay, when boiling starts to happen, you provide latent heat of vaporization. It is the same kind of heat, but we just change the name of the heat. Okay, so why does the temperature remain constant during a change of phase? Now, there's a lot of things for you to copy here, so be ready. Okay, why does the temperature remain constant? If you had followed my argument from the beginning, the temperature remains constant because the heat that is absorbed is used to break up the bonds between the solid molecules. This is the most important sentence in this entire explanation. We have to understand this. Okay, the kinetic energy of the molecules does not increase because there is no change in temperature. That's why the temperature remains constant. Okay, when ice melts into water. Okay, so again, I'm emphasizing the fact, heat can only be used for one thing at one time. It is either increasing the kinetic energy or it is breaking up the bonds between the molecules. Cannot do both at the same time. Okay, okay. So heat that is absorbed is used to break up the bonds between the molecules. Okay? Kinetic energy doesn't increase, temperature, and because temperature is directly proportional to kinetic energy, therefore the temperature remains constant when ice melts into water. Are you providing heat? Yes. Is the temperature increasing? No. Why is there no temperature increase? Because because the heat is being used to absorb, are being used to break up the bonds between the solid molecules. Okay? Change of phase doesn't involve change in temperature. In the single most important thing that you have to get past. It is a mental block, you know. Some people cannot understand, cannot brain this lah. They find that it is too difficult to understand. Okay, the fact that heat can only do one thing at one time. Heat cannot multitask. Okay, and yet humans can multitask. Huh? You can be sitting down in this Google Meet, but actually you're watching the Olympics at the same time. Or you can be sitting down here, you can be sitting down here during the Google Meet, and you are probably sleeping. Okay, or you can be sitting down here during the Google Meet, but you're actually posting an Instagram story about how boring this physics class is. Okay, yet he cannot do that. Heat can only do one thing at one time. Either you increase the kinetic energy or you break up the bonds between the molecules. So heat is a very good student. Wow. Okay, so when liquid boils, okay, the heat absorbed is used to completely break up the bonds between the particles. Okay, it is already broken. We make it break even more. Okay, totally break them up and like no chance of getting back together. Wow. Okay, and the heat that is absorbed is doing work against the atmospheric pressure when the gaseous vapor expands into atmosphere. That's why it involves a lot more heat. Okay, when liquid boils, what heat are we talking about here? We're talking about latent heat of vaporization. Okay, in the previous slide, when solid changes to liquid, this is latent heat of fusion. Okay, latent heat of fusion, if you compare to the latent heat of vaporization, latent heat of vaporization even bigger. Okay, you need more heat because number one, you want to completely break up the bonds between the molecules. Secondly, you have to make sure that the gas is able to go into the atmosphere. It has to work against atmospheric pressure, okay, so that it can go up. So there's a lot of heat that's involved here lah. Okay, latent heat of vaporization is really, 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 really a lot. Okay, so that is the introduction to latent heat. That one also take half an hour, gosh. Okay, but when we talk about latent heat, we need to talk about specific latent heat. Okay, which is just like what we did with heat capacity and specific heat capacity. The word specific, okay, just like specific heat capacity, we're talking about 1 kilogram. Okay, we just have to throw in the word 1 kilogram in there in our definition to make the latent heat definition become specific latent heat. Okay, look back at your notes, and look back at what does latent heat mean. Latent heat is the heat that is absorbed or released. Astaga, even I forgot. Hold on. Latent heat is the heat that is absorbed during melting and boiling without a change in temperature. That's latent heat. Okay, so specific latent heat, okay, will be heat that is absorbed, okay, during the melting and boiling of 1 kg of something lah. Okay, 1 kg of this one, okay, without a change in temperature. When we throw in the word specific, we need to talk about only 1 kilogram. Okay, 1 kilogram of water, 1 kilogram of ice, 1 kilogram of whatever lah. So specific latent heat is the heat absorbed for 1 kg of substance to change phase at a constant temperature. Okay, if there is no word, if there is no specific here, then you just take away this one. Sorry, if there is no specific here, then you just take away the word 1 kg. heat absorbed for substance to change phase at constant temperature. It's latent heat. But when you have specific latent heat, you add the words 1 kg of substance. 1 kg of ice changed to water. How much is the specific latent heat? 1 kg of water changed to ice. Okay, how much is the specific latent heat? Okay, so since we're talking about ice change to water, this is specific latent heat of fusion, which is the heat absorbed for 1 kilogram of substance to change from solid to liquid at constant temperature. It's a lot of things to remember. Okay, and the specific latent heat of vaporization is the heat absorbed for 1 kilogram of substance to change from liquid to gas at constant. Everything is the same now, okay, except that you just have to add the word 1 kg. Why is it 1 kg? Because specific latent heat of fusion and specific latent heat of vaporization are constant values. We need a constant value so that we can compare it to other things. Just like when you were doing your PBL, right? You needed to do a control experiment so that you compare your reading to the control experiment. Okay? And knowing this, knowing how much heat is absorbed for 1 kilogram of substance helps us in our calculation. Okay, which is this next one over here lah. So the formula for specific latent heat, the letter is L. Okay, L for latent. So specific heat capacity was C, bahkan specific heat capacity because of the word capacity, C. But specific latent heat, SLH, okay, we use the L over here. Okay, so latent for L. So L equals to Q over M. Q will be the amount of heat you provide. Unit for Q will be joules. M, as always, is the mass, and the unit for mass is always kilogram. Okay, and L is the specific latent heat. Okay, so take a look at this. If this is joules and this is kilograms, okay, so what will my unit be for L? My unit will be joules per kilogram. Okay, joules per kilogram, or we write it in a more standardized form, joules kilogram negative 1, joules per kilogram. Okay, but we will look into this calculation in the next class lah. Okay, today I kind of want to focus on the theory. Today is a lot of theory lah. Okay, I find that this week all my classes a lot of theory, so I'm speaking more than usual. Okay, so specific latent heat, okay, got two types lah. Just like just now, latent heat got two types. Specific latent heat will have two types, which is the specific latent heat of fusion and the specific latent heat of vaporization. Astaga. Okay, so specific latent heat of fusion is the process between solid to liquid or liquid to solid, depending on whether you're absorbing or release. Okay, and then the specific latent heat of vaporization is from liquid to gas if you're absorbing, and from gas to liquid if you're releasing. Okay, but specific, the word specific means you're talking about 1 kg of solid change to liquid, or 1 kg of liquid change to gas. My question to you is this: when 1 kg of solid totally melts, let's say 1 kg of ice lah, okay, does 1 kg of ice equal to 1 kg of water? Okay, this is a question that I want you to think about. You can actually experiment with this if you want. Okay, when ice completely melts into water, does it remain as 1 kilogram? Something interesting to think about, you know. Okay, it's absorbing all this heat by changing from ice to water, but 1 kg of ice, when it all melts, does it become 1 kg of water? What do you think? Okay, so what does it mean? What does this number mean? 336,000 joules per kilogram. What does it mean? What does it mean by the specific latent heat of vaporization of water? Okay, of water. Okay, is 2,260,000 joules per kilogram. If you remember back from specific heat capacity, specific heat capacity is 4,200 only joules per kilogram per degree Celsius. Means 1 kilogram of water, for example, 1 kilogram of water only needs 4,200 joules of heat energy to increase by 1 degree Celsius. But look at the latent heat of fusion of ice. We're not even talking about thousands, This is 100,000, Okay, 336 100,000. And the latent heat of vaporization is 2,260 joules for 1 kilogram of water. So for latent heat of fusion of ice, 336,000 joules of heat is needed for 1 kg of ice to melt to become water at 0 degrees Celsius. That is a lot of heat energy. Okay, people? There is a lot of heat energy. 336,000 joules. Okay, just for 1 kg of ice. I'm talking about many, many kgs of ice. Change to water. And again, at 0 degrees Celsius. There is no change in temperature. Take a look at the latent heat of vaporization. You want to change 1 kilogram of water to become to boil, okay, to become vapor. You need 2,260,000 joules, okay, of heat just to boil water, okay, at 100 degrees Celsius. Of course, it's for 1 kilogram of water. 1 kilogram of water is, okay, so your big bottle of water, right? The yang air mineral, yang 1,500 mils, right? So 1,500 mils, okay, or 1.5 liters, is about 1.5 kg lah. Okay, so you boil that amount of water. You don't even need to boil 1.5 lah. You just boil 1 kg lah, like 2/3 of the bottle. You need 2,260,000 joules of water just to boil it. And that one haven't included the increase in temperature, no. You just want to change at 100 degrees Celsius. First, you have to increase the water to 100 degrees Celsius. Then only the water changes to steam. Okay, and that one you need 2,260,000 joules of heat. Okay, it's such a big number. Okay, it's such a big number that it's like, whoa. Okay, it's like, oh, it's a lot of heat energy that you need. Okay, so don't waste heat energy. Okay, don't simply boil water for the fun of it. Wow. Okay, so this is what we call a heating curve. Imagine that you have ice. Okay, and ice usually when you start to boil it, when you start to kasih panaskan, it will be actually not at 0 degrees lah. Okay, it will be actually less than 0 degrees. Okay, and then you want to boil it all the way, okay, until the boiling point of water. So in your module, you have all these things that you need to copy down. Okay, so be aware of this. So in every box, okay, that is in your module, you are required to tell me tell me the heat, tell me the temperature, tell me the kinetic energy, and tell me the phase, if there is. Okay, so let's talk about the first one. The first one is L to M. L to M. Okay, the second one is M to N. The third one is N to O. The fourth one is O to P. Okay, these four. So what I want you to do is, I want you to think about all the four situations. We talk about this in terms of all the four aspects. Heat. Okay, in the heating curve, the question that I want you to answer for me is the heat absorbed or released? What do you think? When you heat up something, is the heat being absorbed or the heat being released? Yes, this is your cue to answer. Is the heat being absorbed or released? Okay, the heat is being absorbed. So in your table over there, all four tables, heat is being absorbed because you're providing the heat. So at LM, heat is absorbed. Okay, at MN, heat is absorbed. At NO, heat is absorbed. At OP, heat is absorbed. Okay, so just write the word absorb over there lah. Just to tell you that in the heating curve, the whole process, heat is being absorbed. Okay, that's the first aspect. Second aspect is the temperature increase. Is it? No, temperature. Okay, so you have to tell me temperature. There are only two choices lah. Is it increasing? Okay, or constant? There are only two choices. Okay, tell me which situation where the temperature is increasing and the temperature is constant. The graph will actually tell you. Okay, anyone? When does the temperature increase? When does the temperature become constant? Yalah, saya tahu increase. Bila dia increase? Okay, LM increase, MN constant. Okay. What about NO and OP? Okay, NO increase, all right, and OP. All right, very good. OP is constant. Okay, yeah, fine. OP cons. Oh my goodness. Okay, so OP is constant. So we know this because you can see, kan, this is going from -10 to 0. So obviously here temperature increase. This one temperature doesn't change. This one temperature increase. This one temperature doesn't change. So that's the second thing that you need to fill in all the four. This one, okay. So fill up all the four heats. All the four heats absorbed lah, kan? Okay, then fill up all the four temperatures. Okay, then thirdly is the kinetic energy. Now, what did we say about the kinetic energy? Hold on. What did we say about the kinetic energy? If there is a temperature increase, if the temperature is increasing, the kinetic energy is increasing. Kan? If there is no change in temperature, means there is no that means the kinetic energy is constant. So there's only two choices. Either the kinetic energy is increasing, okay, or the kinetic energy is constant. Okay, so again, tell me which part is the kinetic energy increasing, which part is the kinetic energy constant? LM constant, really? MN increasing. Are you sure? Careful with this, Kinetic energy increases when there is a temperature increase. Okay, very, very important thing. Because temperature increase is an indication of kinetic energy increase. Okay, so Mn and Op is constant. Lm and No is increasing. I always see this no increasing, no emphasis. Actually, it's No, right? Okay, then the final aspect is the final aspect. Gosh, even I forgot what the final aspect. The final aspect is the phase. Okay, at L, what is the phase? What is the phase in L? Okay, solid. What is the phase in M? Okay, the phase in M is still solid. Guys, when there is a change in temperature, the change in phase never happens. Okay, so L is a solid. Okay, M is still a solid, but it is a solid at 0 degrees Celsius. This is something that we have to, okay, something that we really have to wrap our heads around, because we only see it, we only understand what we see, but actually, when we think at the molecular level, this is actually what's happening. You're increasing the temperature, but you cannot change the form. When the temperature is the same, then you change form. Okay, so M is solid, Mn is this solid plus liquid. Okay, it is changing from solid to liquid, and at N, it has fully become liquid. Okay, so this is something like wow. Okay, yeah. People who learn this the first time is like whoa, whoa. Okay, so N is liquid. What about O? O will be liquid as well. Because when there's a change in temperature, there cannot be a change in phase. Heat can only do one thing at one time. Either you change the temperature or you change the phase. Cannot be both. Okay, so when there is a temperature increase, the phase remains the same. O to P is is a liquid plus gas, and then P is fully gas. Okay, so this is how the whole thing will look like. Okay, L and M is hey, this is wrong. Oh no. What am I doing? What is this? Hold on. Sorry, this should be sorry, everybody, this should be solid. Okay, M is still solid. 因为这里 is because over here they write solid. Okay, so M is still solid. Okay, M is solid. M to N is solid plus liquid. N is liquid. N is liquid. O is also liquid. Astaga. Okay, this one should be this is O. This is OP. Okay, liquid plus gas, and then this is P. Okay, sorry for the mistake. And then further than that, when you continue to provide heat, heat is still absorbed, temperature increases, kinetic energy of molecules will still increase. Okay, so notice the pattern, everybody. In the heating curve, heat, bahkan heat is always absorbed. Okay, but at although heat is always absorbed, bahkan, but you find that sometimes the temperature increase, sometimes the temperature becomes constant. But whenever the temperature increases, the kinetic energy of molecules increases. Whenever the temperature is constant, the kinetic energy of the molecules is also constant. Why is the kinetic energy of the molecules constant? Because there is a change in phase happening here. Okay, because there's a change in phase happening here. When there's a change in phase happening here, what is happening? The heat is being used to break. I've said this like a gajillion times a day in this 1 hour, to break down the molecular bonds, okay, between between the molecules. Okay, such a very important thing for us to grasp at this very part of the beginning. Okay, this is only our start into specific latent heat lah. But we need to understand this. Okay, we need to understand what is happening when we provide the heat. It is not just a matter of saya kasih api dan dia kasih panas. Full stop. It's not that, at a scientific level, we need to look at the molecules and see what is happening to the molecules. I wish you can see lah. Okay, obviously I wish you can see. I wish we were in the lab and I can show you, by proving to you, oh, okay, look at the thermometer. Okay, this is this. But unfortunately, I can't. Okay, so we will have to take it as it is. Okay, so for your work today, and actually, if you can, you should just finish this now lah. Okay, I want you to fill in the table in this cooling curve. Guys, if the heating curve, everything is absorbed, the cooling curve, everything happens in the opposite. Okay, so fill in the table in the cooling curve and hand it into the Telegram homework channel by today, please. Okay, by today.